Hey students, welcome to Unit 11. Hope you had a great weekend. Today we're going to be talking about pre-test, post-test study designs. So as you may have gathered from the bell reading, which I hope you've read by now, if you haven't read the bell reading by now, it's a quick 5-page article and has a lot of really important information on that of pre-test, post-test designs, in which we talk about two separate subcategories of the pre-test, post-test design. The first is a pre-test post design of those without a control group. These are otherwise known as quasi-experimental pre-test post-test designs, which we also call within subject study design. The within subject study design is participants and experience both conditions and we don't have any control group associated with it. Without the use of an actual control group, we are in this realm of quasi-experimental. However, it should be noted that this is still a very effective and useful intervention technique that we can use in order to understand our analyses. So, as mentioned before, pre-test, post-test designs are longitudinal in nature, in which we always have participants who come at a pre-test, go through some sort of intervention, and then we post-test them as well to see what the outcomes were from the intervention. Now, as a pre-test, post-test design mentions, it's seemingly essential to always have some sort of pre-test within your design. It is possible to have a post-test only design, but the pre-test makes it all the better in a stronger evidence-based practice. So, your most simple dynamic design of a quasi-experimental within subjects design is that of a one-group pre-test, post-test design. In this design, we have a simple pretest. Now, in these pretests, all we're doing is simply testing people on certain outcome variables and seeing where their baseline characteristics are. Then, coming from an applied research world, we apply some intervention on those individuals. This intervention can be one of several techniques that you use. It could be anything. I personally work in the world of adolescent research interventions, in which we oftentimes provide mentorship towards an adolescent that is otherwise experiencing some negative outcomes or has negative life experiences with that. So that intervention in my world would be providing the adolescents with a mentorship intervention. Then after that, we provide them with a post-test to see was there a change from pre-test to post-test. Now keep in mind there is no control group within this pre-test post-test design, and none of the ones that we talk about in this first set of slides will have a control group. They are extremely beneficial in the sense that we get an excess of change, but we detriment in that we don't have a true control group to compare them to. However, in this case, what our control group is the participants themselves. So participants act as their own control groups, in which they are the pretest to themselves in this longitudinal design. So, keeping with this, all I'm going to be doing throughout the rest of this lecture is providing you different pre-test, post-test intervention designs and explaining the benefits and the detriments of each, and sometimes in the cases where they're either too complicated to perform or quite easy to perform. Our next longitudinal design of pre-test, post-test designs is called a double pre-test design, in which we have two pre-tests where participants serve as their control actually twice, and then proceed on to the intervention, and then proceed on to the post-test. This study design gives us the advantage to see how participants change without with the absence of an intervention. So in this case, they experience two pre-test designs. So we're testing to see, are they changing without the presence of an intervention? Then we designate some intervention and see how long that intervention lasts. It could be 1 week intervention, we get 12-week interventions, whatever your study design calls for, and then we experience post-test. And all we're doing is comparing the differences between each of those pre-tests and see if there's a change. Theoretically, in this double pre-test design, there should be no change from pre-test to pre-test, and the changes from post-test to each pre-test should be exactly the same. As in, there shouldn't be any difference between your two pre-tests, and the differences between each pre-test to the post-test should be the same. If you experience a difference between each pre-test, well, that actually gives you some indication that there's something different happening than your intervention, where really there's just time lapse that's happening and it's causing the change within your post-test outcome measure. So it's really informational to let us know, is our outcome measure, is there a temporal presence associated with it that makes it so that it changes temporally rather than the presence of our intervention, is the purpose of this double pretest design. Our next pretest post-test design is called one group with a non-equivalent dependent variable. Notice that we're able to call this a dependent variable because we have this control group of itself. Although it is quasi-experimental in nature and a within groups design, it is still considered a dependent variable because we have this comparison group, even though the comparison groups is themselves. In a non-equivalent dependent variable design, what we have is where you are measuring at your pretest your main outcome variable of interest, and additionally measuring some non-changing variable as well. This could be anything like height that you would not expect to change, or some sort of measure that you wouldn't expect to change. Some sort of personality characteristic could be in there, unless there's some way your intervention was focused on personality. You would just be testing that to see, is there a temporal indication of changes that aren't associated with your dependent variable. So in this case, it looks like a simple pre-test, post-test design, but we are also measuring other variables that aren't expected to change. If we are seeing changes in our variable that we wouldn't expect to change because of the intervention, well, that's indication of a problem with our study design or problems with the variable that we're measuring, because the indication that you are seeing multiple variables change, although they were not supposed to change from your intervention, gives indication that something is going on in your intervention that should not be happening. So really, as you can see from our pre-test, post-test designs, these really double in their nature of what they can do. First, they can check for errors in our study design. Next, we're able to see differences from pre-test to post-test to assess changes and the strength of our intervention. We can get effect sizes, we can understand p-values, we can see what the changes are in our participants from pre-test to post-test. Our next pre-test, post-test design is that known of removed treatment design. In the removed treatment design, we can split it up into two separate groups here. You'll see that the first three bubbles from these images indicate a general pre-test, post-test design, in which we have one pre-test, the intervention of interest, and the post-test, which measures our outcome variable of interest again. However, similar to the pre-test design, we now have multiple post-tests, and this gives us a lot of different advantages here. So, to start, we can compare the post-test to our pre-test. Next, we can compare the post-test to another post-test, and this has a lot of advantages. We can see how well does our intervention hold up over time. From a longitudinal sequence and temporal change, does our post-test hold up? Does our outcome variable of interest change with the absence of the intervention? Theoretically, we call this dosage levels. We expect that without the exposure of the intervention, so the dosage of the intervention, we would expect that there could potentially be a change from post-test to the next post-test with the absence of the intervention. In this case, is what we see. However, it could also be the case that there is no change from post-test to the next post-test design, in which case we can say there's a strong presence of our intervention, that the dosage level doesn't need to be there, in which case we only need one presence of the intervention to keep up the outcome variable of interest. So take, for example, if our outcome variable of interest was, let's say, depression. So in this removed treatment design, we would first measure depression, run them, through some intervention designed to treat depression. Let's take it for example, a therapeutic program designed to treat depression. Then, in the post-test, measure depression once again and simply compare the difference from post-test to pre-test with the presence of the intervention. Now, with the removed treatment design, we're also interested in saying how well did our intervention hold up over even more temporal change in time. Let's say we were interested in long-term outcomes. How much does depression change after 6 months of not being exposed to the intervention of the therapy? Did depression change from post-test to post-test? And we give it a 6 months time. I additionally included one more aspect where you can continue these post-test designs for as many times as possible to get the longitudinal aspect to see how well your intervention works in the long run. That's the real great advantage of using a removed treatment design, is that we can understand how well our intervention of interest works on a longitudinal time frame. So you can do a pre-test right before the intervention, proceed and give them the intervention. So in our case, in the therapeutic treatment to treat depression, then provide them an immediate post-test. Then, after you provide the immediate post-test, you can see how well does the long-term work, how well does it work 6 months after, and then we can test again. How well does it work 12 months after? Are our participants still increasing, having lowered rates of depression after going through our intervention, even with the absence of the intervention? I'll tell you, in therapeutic programs, it's very likely that they need to have continual dosage of the intervention, but it's an interesting aspect to think about in hand. We can now talk about experimental pre-test, post-test designs, those that actually have a control group associated with them. These are very advantageous to have a control group and to have an actual comparison group, which makes it truly experimental. We call this a between subjects designs that we can compare from a treatment group to a control group, so that we can actually measure differences between the control and the treatment group. Let's talk first about the two-group pre-test, post-test design. This is a pre-test, post-test design in which we have an actual control group. This is an extremely powerful design to have because we're able to measure those to see how well the intervention works from a longitudinal perspective, having that within subject design in which we have participants compared to themselves, while additionally and concurrently having the comparison group as well, in which we have a pre-test design going straight through without an intervention and having a post-test. This is an extremely powerful design. We have many different aspects that are associated with this. And let's talk them over, right? So let's look at our image. We have our program participants and then our simple comparison group. The program participants is essentially a pre-test, intervention, post-test design, pre-test, post-test design with the presence of an intervention. We're now comparing those that took the post-test to themselves at the pre-test, while additionally having a comparison group. In the comparison group, you're randomly assigning individuals to this pre-test, and they simply run through the same amount of time, so that temporal sequence of time that the intervention would take, whether the intervention takes 1 week, 2 weeks, 3 months, 12 months, 5 years, it doesn't matter. They just need to run through the same amount of time that the intervention would last without the presence of the intervention. Then we give them a post-test design and say, how well do people do just over time? Then we can compare the group with the post-test as well and say, is there a difference between our groups? So you're answering two questions at the same time, whereas within the non-control group aspect, we are only able to answer one question. Our questions that we're able to answer now is A, do people change over time with the presence of an intervention given our pre-test, post-test design? Additionally, do those that run through an intervention differ in terms of how they do in terms of your outcome variable. So again, as you know, one of my favorite outcome variables of interest is depression because I work a lot with depression in adolescents. What I'm asking here is, did individuals get better from the intervention on the outcome variable of depression? Additionally, when we compare those individuals to other individuals with the outcome variable of depression who do not run through the intervention of interest, do they experiencing some changes at all just from some longitudinal aspect of design? Perhaps without the comparison group, perhaps what we would be seeing is that people generally over time become less depressed. If we didn't have the control group there or the comparison group, we wouldn't be able to capture that aspect of it. And lastly, I want to talk about randomized controlled trials, in which is just a special case of our control group within subject between subject design. And really, I think you're going to find that most study designs utilize this random controlled trial aspect, but it's really just identifying all the steps that I think you would be doing anyways. So, in a randomized controlled trial design, all we're saying is that we get our study population of interest, we apply our inclusion and exclusion criteria that we discussed in the study sampling section, then we get our study sample, then, which you've already learned about from our experimental section of the lectures, we randomize, and remember we randomize either through some sort of coin flip, random number generator, we randomize people to either an intervention group or a control group. Then it's simply the same as our experimental design, pre-test, post-test design, with an experimental group, with a control group associated with it. Is really all it is. You're going to find that a lot of scientific journals out there that utilize a pre-test, post-design with a control group will be saying that they conducted a randomized controlled trial because really they did randomly select their participants. They did randomly assign their participants to either the intervention group or the control group to assess our outcomes of interest and compare those individuals with themselves. So in the intervention group, in which we compare themselves with the outcomes to their pretest, while additionally comparing them from their outcomes of interest to the comparison group to see if there was just some sort of change that happened, potentially longitudinally or temporally. So that was a pretty quick lecture, right? Great. Because there's not so much to pre-test, post-test designs that you haven't learned already. If you need more understanding of this, you can go back and refer to our experimental design lectures where we talk about the differences between groups and within group subjects and mixed designs. But really, in summary, what I like to say is that there's many options for pre-test, post-test designs. They actually go beyond that which we talked about. If you want to read the entire Bell paper, you can get a good understanding of all those. However, I felt like those all went beyond the scope of this class, so I didn't want to talk about them in total. Additionally, each of them has their own advantages and disadvantages. You can also mix and match some of these study designs so that you have a pre-test, post-test design as well. There's a lot of different ways to do it. But once you get the understanding of what a pre-test and a post-test design is, you kind of can mix and match things so that they work appropriately. Additionally, I didn't mention this before, but the randomized controlled trial is considered the gold standard study design. These are oftentimes the study designs that you'll see in medical treatments, interventions that have been going on for a while. These are considered the gold standard because they have that random population. They have random sampling from the population. Then, so number two, they have random assignment, which is an extremely important aspect of a experimental control design that allows for this understanding so that we can compare groups equally, and then allows individuals to be in the intervention group or the control group and run through the pretest and or the intervention or not having the intervention, and then doing the post-test design. Our next lecture, Unit 12, Meta-Analyses, is going to be a little bit longer. This is where we're talking about all the aspects associated with a meta-analysis. A meta-analysis, in general, is a study of studies that have been published in the scientific literature. And we're about to dive in deep about what a meta-analysis really is. So our objectives today are to A, learn what a meta-analysis is, and then B, walk through the steps of a meta-analysis. Now I really wanted to just walk through the steps of a meta-analysis today so that we can get a good understanding of what it will be like when you read a meta-analysis as well, because in order for a meta-analysis to be properly conducted, there are very specific steps that you need to follow for it to be considered a true meta-analysis, which we'll be discussing in the following slides. So let's start off talking about what a meta-analysis is. A meta-analysis is the statistical procedure for combining data from multiple studies. Now I want that to be a point of interest for you. So this is an actual statistical procedure in which we get either tens of studies, hundreds of studies, thousands of studies it can be, and then concatenate them into one aspect of them. And what we're generally interested in is the effect size from each of those studies so that we can get a generalized effect size for some sort of treatment of interest, some sort of outcome variable within a population of interest. So when the treatment effect is consistent from one study to the next, meta-analyses can be used to identify the common effect. And we're going to dig in a little bit deeper as to what those common effect size measures are that we're interested in, while additionally focusing on the steps that it takes to combine these data from multiple studies so that you can say that you performed an actual meta-analytic review. So I want to sum up before we even get started what a meta-analytic review is. In short, when you are performing a meta-analytic review, you read a lot of scientific articles pertaining to one outcome variable, or it could even be an intervention of interest. So we read a lot of scientific articles. This takes a lot of reading and a lot of time. We're going to discuss it, and it's actually going to seem relatively easy to perform a meta-analytic review by the end of this lecture, but once you start doing it, you realize how much time and how much effort it really takes. So every time you see a meta-analytic review in the literature that you get to read, you're going to say, wow, they took a lot of work to get this. But essentially, you read a lot of scientific articles pertaining to one outcome variable, then you grab the effect sizes from each of them. And remember, we talked about effect sizes before. This could be correlations, this could be a Cohen's d. There's a lot more effect sizes out there that we haven't really discussed, but whenever you see them say we grab some sort of effect size of interest, then we simply say we combine them all. And then you combine them all together to get the average effect size. And this is extremely helpful to literature reviewers and people who are reading through the literature because they need a good understanding of what just a generalized effect size is for them to perform their own literature and to perform studies. In today's lecture, we'll be talking about the 9 steps to conduct a meta-analysis. These steps come from a seminal article that came out in 2017 by Arindam Basu. Now, Basu essentially ran through and gave out something called the grade criteria in order to understand the correct way to conduct a meta-analysis as a framework for anyone conducting a meta-analysis in the future. Now, the reason I'm giving you these steps is because when you read a meta-analytic review in the future, or theoretically even you perform your own meta-analytic review in the future, these are the steps that either the authors or you as the potential author in the future go through to perform a meta-analytic review. And we're going to go ahead and go to the next slide. On this next slide, I made it a little bit easier to talk about what steps we're going to be talking about. So even though it's 9 steps in general, we're only going to be talking about these 8 and the parts that I kept here. So in meta-analytic reviews, we use the following 9 steps, but we're only going to talk about 8 of them today in order to run a meta-analytic review. So our first step is to frame a question based on a theory. And remember, we learned from previous class how to frame a theory and what a theory is. Then we're going to run a literature search using PubMed or PsycInfo, Medline, Google Scholar, which again, you've already learned how to do this in a previous class. So really, 2 of the steps you're able to do on your own already. Next, we're going to read the abstract and titles from every single paper. So notice how they don't even advise you to read every single paper. That's because when you run these searches on your variable of interest or a frame research question of interest, you're going to get so many articles that you simply don't have the time to read every single article, so you need to read the abstracts of each individual papers. Then, from the abstract information, you select the set of final articles that you feel, based on your research question, relates to your meta-analytic review. Then, we determine the quality of information of each of these articles by actually reading the articles fully, and it will be a judgment of the internal validity of the study, which we've talked about in previous classes before about what internal validity is. Remember, internal validity is how well was this study designed? Was it an experimental study design? Was it a correlational study design? These will all have aspects that you'll need to understand in order to conduct a meta-analytic review, or even understand why these authors in these meta-analytic reviews that you might read later would weight their variables in order to get a common effect size. Next, we do something called determine the extent to which these articles are heterogeneous. Heterogeneous meaning how different are these articles? That's all we're asking in step number 6, is saying, are these articles very similar to one another, or are the ways that they design their studies in the articles very different from each other? Theoretically, you want the studies to be very similar to each other. That way there's not a lot of variation in the way that we conducted our studies. Then we estimate our summary effect size and construct a forest plot. And I'll be talking to you later about what a forest plot actually is and how it's beneficial when reading meta-analytic reviews. Lastly, we're going to determine the extent to which these articles have publication bias and run a funnel plot. And again, I'll talk to you more information later talking about what a funnel plot is and how that determines publication bias in the research literature. So we're going to go ahead and just discuss each of these steps in more detail in the following slides, so that when you read a meta-analytic article in the future, you'll understand the steps that they took to get to where they are and understand each step in general, so that you have a good understanding of the meta-analytic reviews that you'll be reading. So for step 1, what we need to do is frame our question of interest when we're performing a meta-analytic review. That seems pretty self-explanatory. In fact, you should know how to frame a research question by now. You know what a theory is. You know how the concept of going from a theory to a research question to a hypothesis is at this point in the class, because we've discussed it in as early as lecture 1, where that was the first topic of interest that we wanted to talk about, is what is a theory and how can we develop hypotheses from a theory. So really, the problem is this isn't as self-explanatory as you might think. Although coming up with a theory is particularly important, your research question needs to be quite specific, because if you have too broad of a research question, then you're going to be pulling in lots of articles that don't necessarily relate to the outcome variable of interest. It's going to be quite difficult to really narrow down things and actually simplify things enough in your meta-analytic articles to talk about them. What we need to do is indicate something called inclusion and exclusion criteria to constitute what is part of our research question. So, inclusion criteria is any criteria that you decide to choose that you think is necessary for it to be part of your meta-analytic review. Exclusion criteria is the exact opposite. Exclusion criteria, we say, if an article contains this piece of information, we will automatically void it from our pool of potential articles that we will be using. So an example of inclusion criteria. Sometimes we need to compare a certain effect size. So we use inclusion criteria in which we state we will only be collecting articles that reported this certain effect size. So there's two effect sizes that we have learned about in this class, which is correlations and Cohen's d. So as an inclusion criteria, I can say I am only going to include articles that contain the effect size of Cohen's d. Next, we can talk about exclusion criteria. Exclusion criteria is a way of saying what we are not going to include in our study. So, take for example, I will say I will not include correlational studies. I only want to include those with higher internal validity. Therefore, I will exclude correlational studies from my meta-analytic review so that all of my effect sizes of interest are those that are experimental. And there's a lot of different types of inclusion and exclusion criteria that you can place on your meta-analytic review to have the best meta-analytic review possible. Next, we need to run a literature search. Luckily, you already know how to do this, but this is like doing a really intense, in-depth literature search in which you need to compile every single article that has been posted on that subject or something that's associated with your research question of interest over the past 10, 20, 30, 40, 50, even 100 years, however far back it goes, that your research question of interest has been tried to be answered so that you can compile them all into one database to talk about it. This is where it's really important to have good inclusion and exclusion criteria, because if you don't have the inclusion and exclusion criteria of interest, you're going to be getting a lot of articles that are not associated with your outcome variable of interest, that are not associated with your research question of interest, and therefore you're going to get in a lot of trouble. So that's why it's so important to run these meta-analysis in certain steps, in which case we've already determined the inclusion-exclusion criteria before we have started our literature search, so that we have a clear understanding of what it is we will be doing for our literature search. Next, it's simply read the abstracts. From your literature search, you're going to have to read every single abstract. Now, this is a point where I want to come and say, normally, meta-analyses are not done individually. You usually have a team of researchers who do this all at once. So a key to meta-analytic reviews and doing meta-analyses is to have a compiled team of researchers and to collaborate with your fellow researchers in order to perform these proper meta-analyses. It'll take the burden off of you completely to have to read every single abstract, because sometimes you need to read hundreds of these, and it's good to get a good headspace together where you have many other researchers who are experts in your field with you to read this. So when you're reading these meta-analyses in the future, you'll find that oftentimes these are not just one author, that oftentimes these can have, I've seen up to probably 15 to 20 authors on one meta-analysis before, because we need a lot of head power in order to read all these abstracts and determine what fits the true inclusion and exclusion criteria. And that's exactly what you need to do, is when you're reading these abstracts, is determine what fits your inclusion and exclusion criteria. Next, we want to reduce to only the abstracts of interest and summarize each of these articles even further. So once we've actually reduced it to abstracts of interest, it's actually a necessary component for you to read every single paper in all detail, so that you can summarize each article even further. Then, for each article, you can do this using an Excel sheet of some sort, or some sort of programming software that you think is interesting, in which you determine what the main IV or predictor was in each of these articles. And depending on what your research question of interest is, you'll be checking what their research questions were, and additionally checking to make sure that the correct dependent variable was properly defined in each of these studies that you have for this meta-analyses. Now that we've actually reduced things to something that's more readable and only to objects of interest, while additionally setting our inclusion and exclusion criteria, we can now try and determine how well run each article was. And really, what you're doing here is determining how valid are these studies that have been performed in the past. Remember our conversations about internal and external validity before? That's exactly where these come in. You, as the researcher, will be determining how well these studies were run. Are they internally valid and are they externally valid? So, for example, you have to ask yourself, was it an experimental study? We know that experimental studies generally have higher internal validity as compared to their correlational study brothers. Um, in this case, you're asking, are they experimental studies? If it is an experimental study with the caveat that it is a well-run experimental study, remember I said just because it's experimental does not necessarily mean it has high internal validity. It's about how well run the experimental study was. So you as the researcher running this meta-analysis needs to determine if that was a well-run study in order to gauge the internal validity. If it's a highly internally valid study, then you simply say, I'm going to add more weight to how well this study is going to determine the averaged effect size because it was highly internally valid. Another thing that we oftentimes are interested in is how many participants were included in the study, because more participants is often an indication of higher external validity. But again, I have this caveat. Remember, um, as I asked you on one of the quizzes, additionally, what we learned about with sampling is it's not about how many subjects you have in your study, but whether or not that truly represents your population of interest. But in a meta-analytic review, it's kind of the hope that with more participants, you're better representing your population of interest. So the more participants there are in a study, generally we conclude that that's a higher, more externally valid study, so we give more weight to those studies that have higher external validity. So here what we're doing when we're determining how well run each article was, we are truly actually determining how much weight are we going to provide each of these studies individually. For step 6, we're going to be doing something called determining heterogeneity. So heterogeneity might be a little bit complicated of a word, but really all it means is difference. This is one of those things where I say, why don't we just call it determining the difference among studies? I don't know why, but in psychology we have certain terms we like to stick with, and heterogeneity is one of those words. So whenever you see the word heterogeneity, just think different. So really what you're saying is, how different are these articles from one another that I've picked up and compiled? Do they all have the same set of predictor variables, or independent variables if it's an experimental study? Are these experimental studies? Again, this is where again you're determining how different are these studies from each other. Ideally, you want less heterogeneity within your studies. However, that's not always the case. You can have too few of studies if you set too strict of inclusion or exclusion criteria, so that the more studies you have, it's a trade-off, right? You can have more studies, or you can have more heterogeneity in studies, is where we're looking at here. So in general, you want combination in order to find a balance between the two, where you have lots of studies while additionally keeping them as homogeneous as possible, homogeneous as possible, but that you can't always do that. So it's a trade-off, and you need to strike a balance between the two of whether you're going to have a lot of studies or you're going to have very similar studies. The more different these studies are from another, the less we can be sure that these studies fit together. And so when we compile that effect size, we'll be less sure about how true that effect size is towards our population of interest. So that's really what you're doing. And I want us to also point out that a lot of this falls onto the subjective nature of the researcher, which is an unfortunate thing. As researchers, we oftentimes prefer objective cases, but as you can see in each of these steps, um, it's a lot of subjective taste of the researcher. That's why it's so important that we have these steps. And I think you're going to find that when you read meta-analytic reviews, you'll find that it is very necessary component for you to be very detailed in what you did in every single step of this process. That's why this article is so seminal, that I'm basing this off of, because it gives a objective way of such a subjective process so that the reader themselves can make a determination of whether or not your meta-analysis was good or not. So remember, the step 6 is to determine heterogeneity. So essentially determining how different are the articles that you chose are from one another. Next, we have something where we develop a forest plot. All a forest plot is to determine and help the reader visualize how heterogeneous were these studies. So, additionally, these forest plots tell you what the generalized effect size is. So, was the overall effect size of the Cohen's d, did it end up being a small effect size? Was it a medium effect size, or was it a large effect size? And that's what a forest plot does. And on the right here, I show you an image of what an actual forest plot looks like that you would see in really just about any meta-analytic article that you read. So, if you look at your image that is on the right here, what you see is first a column indicating which study it is. So there's study number 1, study number 2, study number 3, and study number 4, and then additionally what the overall estimate is. To the right of that, you get these boxes with lines in them. The squares indicate one study in which you got the average effect size. So for study 1, it looks like if you look at where that square is, they got an average effect size of about 0.3. So this could be a Cohen's d, or this could be a correlation of 0.3 or some sort of effect size. Then we didn't really quite learn about this yet, but those lines that come across from those squares are called confidence intervals. We didn't learn about what confidence intervals were. That's really for your next class in Psych 350, where we will discuss what confidence intervals are. But essentially, a confidence interval determines how confident was this study in determining the actual effect size. Were they very confident that that was the true effect size, or was it very unsure? The longer those bars are, the less confidence we have that that effect size is true. Lastly, we have this kind of diamond that goes to the right of the overall estimate. That is the sweet spot. This is the end product of every meta-analytic review. This is what a researcher really reads a meta-analysis for. It's for this overall estimate of the effect size. So, let's say we're interested in the relationship between those who go to therapy and those who experience levels of depression. In which case we want to see, is there a certain therapeutic treatment that we've done lots of studies? So for example, one therapeutic treatment that is often cited in the research literature is cognitive behavioral therapy. And we're asking the question, how effective is cognitive behavioral therapy? So in this case, when we're comparing we would go through all these steps and say, A, we have a research question, and our research question is, how effective is cognitive behavioral therapy on levels of depression in a adolescent population, we'll say. Notice how I had all those characteristics in there. I defined my research question. I determined my outcome variable of interest, and it's also an indication of what my independent variable or predictor variable was. And I additionally indicated what my population of interest is, which is very essential to any kind of research question or hypothesis. Then I go through and I run through all of these steps that were previously mentioned, where I find any study that has cognitive behavioral therapy and levels of depression. Then I can conduct this forest plot to determine how well each of those studies were and what the overall effect size is. So let's say I determined that these were all experimental studies, so I only included variables that had a Cohen's d. Each study had a Cohen's d in it. In this case, my overall estimate is a 0.4, which we determined is a moderate Cohen's d. So really, we're saying across all of the literature that I conducted in my meta-analytic review, we got an overall effect size and an overall Cohen's d of 0.4, indicating that in general, cognitive behavioral therapy does a moderate job at treating depressive levels within adolescence. And that's really what a forest plot is. It's just a visual display of what all these steps were and how it got to the overall estimate, which is the big picture that we get from a meta-analysis. The next step, and the final step that we'll be discussing in this class, is creating a funnel plot. A funnel plot looks for something called publication bias, otherwise known as the file drawer problem. This is a huge problem within any scientific field called the file drawer problem. Essentially, the file drawer problem is studies that don't have significant results tend not to get published. Therefore, they're not shown in the literature, and we didn't get a chance to read the literature that had an insignificant result. What this funnel plot is showing us is where publication bias exists. Really, the main thing you need to look at, and really, I promise you, in every meta-analysis that you read, you will see a funnel plot, so it's important that you learn it now, what it is. All you're really doing is looking at the plot. You really don't need to focus on the X or the Y axis, you just need to look at where the dots line up. When the funnel plot is symmetrical, as shown on the upper right hand of your slide, this is indication that there's no publication bias. And really what that's saying is, in our meta-analytic review, we're able to find studies that supported the treatment and studies that did not support the treatment, as would be expected if there wasn't publication bias. However, as can be seen in the bottom right of the funnel plot, you can also have an asymmetrical funnel plot. And what this is saying is that oftentimes what we find is that there's a heavy favor in one direction, oftentimes in the direction that favors some sort of intervention or a research question of interest, that indicates that there's publication bias. So what we say is that all the studies that have been conducted are usually in a positive way, indicating that our effect sizes are in some way biased. That if it's asymmetrical, our effect size of interest is biased, and indicating that it is overinflated and that we need to use caution when interpreting this effect size. So, in the case of an asymmetrical funnel plot, which I will say is most often the case in most meta-analytic reviews that you read, is that they will result in an asymmetrical funnel plot, we're indicating that there's bias in the literature and that the effect size that we see from our meta-analytic review is skewed so that we are only seeing the positive results, so that this is an overinflated effect size. In summary, what we're saying is that people are looking to do better than they really should be from the literature. This cognitive behavioral therapy that we're talking about from the last example may not be as effective as it seems in the literature, because we're not seeing the other half of the story, and that means the times in which the literature did not show an effect, that really in some indication there should be points in which cognitive behavioral therapies did not show a effect on depressed adolescents. So in summary, a funnel plot, all you're really doing is looking to see, is it symmetrical or not? If it's symmetrical, that means that there's no indication of publication bias. If it's asymmetrical, it means there is evidence of publication bias, and we should be wary of the results that we got. So when you are reading a meta-analysis, I wanted to give us 2 important points. You can use all these skills to help understand what is going on in a meta-analysis, and I would actually encourage you to go right now onto a literature search and find a meta-analysis of a subject of interest that interests you. Find one on cognitive behavioral therapy and adolescent depression. I bet there's one out there about the effects of it. And you'll see that they all go through these exact steps to talk about their meta-analytic reviews. It will be filled with a lot of big words, but focus on the main effect size. You're going to read through a lot of things which are going to be these steps that we just discussed, but focus on the end goal. What was the effect size they got? Additionally, look at those funnel plots and say, did this indicate an area of potential publication bias? So should I be wary of the effect size that was determined from this meta-analytic review? So in summary, meta-analyses are a way of compiling the research literature and getting an overall effect size. This is a very methodical process with a subjective nature at each step. Although subjective at each step, it's methodical, and the purpose of having this methodical process is so that you can be honest to your reader about how you conducted the actual review. These meta-analyses allow for an average effect size and look to see if there's publication bias present within the literature.